Okay, so time to actually start the machine up. This is prior to loading the path. This is preparing the machine for cutting. You'll see that I've got my work holding already in the machine, my stock piece in the machine. What I did in Rhino is I printed out a 1:1 image of the part so that I can come out here with my jigsaw and chop up a block of wood to the adequate size. Now, the decision making on how much stock you use is generally done before you path. You know how much stock you have, but in this case I've got a large block of wood and I only have to cut off what I need. My second decision about cutting is I don't have a table vise big enough to hold that block of wood, because if I come this way, there I run a risk of the spindle hitting the fourth axis, and when I go that way I've got to move my Z probe for the vise that I do have. So I've opted to just cut the part a little bit, the stock a little bit bigger than I need, countersink two little holes into it and actually bolt them directly onto the table. Now you've got to remember that the machine will cut whatever you ask it to cut. Now in our pathing we had a curve running around here and we said extra for cutter. Alright, so the cutter is 317 millimeters, which means it's going to go outside this line by 3.17 millimeters. And if you'd cut this too short and the screws were too close, the likelihood of actually hitting that screw is fairly high, and you will break a cutter, possibly your spindle. So always double check how much work holding you have. I generally then also measure, not sure it'll show up in the video, I measure my center lines through the stock part. Now you don't have to go through these steps for majority of stuff, but just while you're learning, probably not a bad idea. Okay. Always clean up the machine before the time. I blow it down with compressed air, make sure everything's clean, blow off the screws, and I fit the first cutter we're going to cut with. So today that's a 317 end mill. It's inside there. You fit the cutter, you have two spanners. Their nicknames are Where Are You 1 and Where Are You 2. The smaller one goes in the top and the bigger one goes in the bottom, and it just tightens up the cutter into there. You don't have to go Tarzan on it, you just got to nip it down nicely. Okay, going Tarzan you can actually hurt the collet. The other parts that I keep on my milling machine, you can see I fit a little magnetic strip against there. Is lose it 1 and lose it 2. Those are the two little holders for my fourth axis. They give you leverage for locking down the 4-jaw chuck. Okay, and of course my hex key for components like that, where I'm locking stuff down onto the table. I keep all my cutters that I'm going to be working with close by on this. I keep them actually in another location, but for what I'm cutting today, I bring them out. So the two cutters today are the 317 that's in there, and then the tapered ball end mill, half mill ball. Okay, so that one's nickname, by the way, is Stabby Stabby Bleedy Bleedy. Don't ask me how it got that name. Okay, so the milling machine, as you're aware, has a Z-axis, a Y, and an X, and in some cases you're going to use a rotary axis, which is A. If you want, you go up to 5-axis, which has got an A and a B. So that whole table rolls and it gives you more access to more parts. There are upsides and downsides to the different configurations. If you didn't have the 4th axis on here, you'd have a lot more free space for cutting, but it's quite painful putting that on and taking it off, because you've got to tram it in so the pitch, the yaw, all the angles are straight, so that when you're cutting stuff it doesn't end up all wonky. Okay, so as far as possible I try to leave the 4th on if I can. It's also the reason I don't have the 5th on. With the 5th on, the 5th picks the part up so high that I got virtually no cutting area in Z. I'm working on a plan to fix that. You have a tool probe over here. It will be used to tell Mac where the end of the tooltip is in the next step that we get to. So always double check around the machine that there's nothing laying underneath any of the screws. It's going to get hit while the machine's moving. Check all your cabling is up and tight. Okay, generally speaking, these are damn good mills, and I've never had an issue with stuff coming loose or falling, but there is the mechanical failures that can happen because you forgot that you left your glass of whiskey on the side and all kinds of things like that. The electronics for the part I store underneath here will look very similar to what you have. You have the actual controller, you have a spindle controller, and the controller PC. Now the controller PC I've already powered up. I always leave all the other equipment off while I'm powering up the PC, because you never know what's going to happen with stray USB surges and stuff like that. The last thing you'd want is that machine to start moving, not under your control. This speaks to the controller PC via USB, and this speaks directly via a network cable, RJ45, to the machine. So now that the controller machine is fired up, I'm going to turn on the spindle. Okay, and then I'm going to turn on the controller. And then we're going to fire up Mac. So yours will look similar to that. I'm going to just use my 5-axis config, because whether it's on or off, I can still choose not to use the other axes. When it fires up the first time, you're going to see the little reset button flashing, saying we've got to just hit the reset button to make sure the connection is good. And you now have control over Mac. I'm going to do a little bit more in-depth video using a screen recorder for Mac on all the different settings and what they do. But out the box, yours will be configured correctly to datum the machine. So what we're going to do now is we're going to hit the little button called Home and Probe, making sure, of course, that you must have a cutter in. If you don't have a cutter in, you're going to probe the bottom of the spindle, probably even crash the machine. What's going to happen when I hit that button, there are little on-ROM switches underneath the axis limits of every table and behind Z, and the machine's going to drive, find the limit switch, bounce off of it, find the limit switch, bounce off of it, find the limit switch, bounce off of it, and go to a pre-programmed position to look for the tool probe position. Now always be near your machine, always have your hand either over E-stop, big red button, or over the escape key on the keyboard, just in case anything goes wonky, if it starts moving in a direction you weren't expecting it to move, or anything's gone wrong with your setup. So I'm going to run it now. That's touched off Z, touching off Y, touching off X, and it will come back and bring the cutter down. Let's see if I can zoom that in for you a little. And that is probing done. Now the machine knows where it is, or Mac knows where the machine is, and we're able to start setting up all our offsets for our work. Now that's a separate video, and I'll come back to it.